Have you ever looked up at someone's roof and noticed those dark, sleek panels just sitting there under the sun? Maybe you've driven by a massive field full of them, all tilted at the same angle like they're worshiping the sky. And you wondered, how on earth do these things work? How can a bunch of flat, quiet surfaces just sit there and create electricity day after day without a single moving part? Well, that's what we're going to talk about today. Because behind the silence, there's an incredible story of science, engineering, and the power of the sun. Let's start with something we all take for granted: sunlight. The sun, that massive, glowing ball of nuclear energy floating in space, is the reason life exists on Earth. Every second, it releases an unimaginable amount of energy, most of which shoots off into space. But a tiny fraction of that energy, about 1/2 billionth, reaches our planet. And yet, that tiny bit is still more than enough. In fact, every hour, the Earth receives more energy from the sun than the entire world uses in an entire year. That's right. 1 hour of sunlight could power humanity for a full year, if only we could collect and store it efficiently. Enter the solar panel. You've probably heard the term, maybe even seen installations in your neighborhood. But how does it actually work? At the core of each panel are solar cells, thin slices of semiconducting material, usually silicon. These cells are arranged into a grid, and when sunlight hits them, something fascinating happens. Light particles, known as photons, knock electrons loose from the atoms in the silicon. This movement of electrons creates a flow of electric current. That's what we call electricity. But the electricity produced at this stage is in a form called direct current, or DC, meaning it flows in only one direction. That's great for batteries, but not for most of the appliances in your home, which use alternating current, or AC. So the next step in the process is the inverter. The inverter takes the DC electricity generated by the solar panels and converts it into AC power that your home can actually use. From there, the electricity flows through your breaker panel and powers your lights, your refrigerator, your laptop, everything. Now here's where it gets even cooler. On sunny days, your panels might generate more electricity than you're actually using. What happens to that extra energy? If your system is connected to the power grid, which most are, that excess electricity can actually be sent back into the grid, and you'll often get a credit for it on your electricity bill. This process is called net metering. It's like your electric meter runs backwards, saving you money every time the sun is shining and you don't need all the power you're generating. And at night or on cloudy days, when your panels aren't producing much electricity, you just draw power from the grid like normal. But what if you don't want to rely on the grid at all? That's where solar battery storage comes in. Systems like the Tesla Powerwall and others let you store excess electricity during the day and use it at night or during power outages. It's like having your own little power station in the garage. Though batteries do add to the cost, they also offer greater energy independence and resilience. So what makes up a typical solar power system? First, there are the solar panels themselves, usually mounted on your roof or sometimes on the ground. Next is the inverter, which we already talked about. It's like the translator between your panels and your home. Then you have the electrical panel, which distributes power to your circuits. There's also the meter, which monitors how much electricity you send to and pull from the grid. And optionally, there's the battery storage system and a charge controller, which ensures that your batteries don't get overcharged or drained too deeply. Okay, so now you know how solar panels work. But why should anyone care? Why are people, governments, and companies all over the world so focused on solar energy? Well, the big reason is this: solar power is clean. Unlike coal, gas, or oil, solar energy doesn't emit carbon dioxide or other greenhouse gases. It doesn't pollute the air or water. It doesn't need to be mined, transported, or burned. Once installed, it just sits there, harvesting light and turning it into power with zero emissions. It's one of the greenest, most sustainable forms of energy available to us. Second, it's renewable. The sun isn't going anywhere for at least another 5 billion years, which means we've got a virtually unlimited energy source shining down on us every single day. And unlike fossil fuels, we're not going to run out of sunlight. It's available everywhere, in deserts, on rooftops, even in space. Third, it's getting cheaper. In the last 10 years, the cost of solar panels has dropped by over 80%. In many parts of the world, solar is now the cheapest form of new electricity generation. That's right. Cheaper than coal, cheaper than gas, cheaper even than wind in some places. It's no longer a luxury or a science experiment. It's a mainstream, practical solution. But it's not perfect. Like any technology, solar has its challenges. The most obvious one is that it only works when the sun is shining. No sunlight, no power. That's why most systems still connect to the grid or use batteries to cover gaps in generation. Another issue is the upfront cost. While prices have fallen dramatically, installing a full solar system can still be a big investment, often tens of thousands of dollars before incentives or rebates. However, with savings on electricity bills and government support, most systems pay for themselves in 5 to 10 years. After that, you're essentially generating free electricity. There are also issues with space. Not every roof is suitable for solar panels. Some may be shaded by trees, poorly angled, or just too small to make the system worthwhile. Ground-mounted systems are an option, but not everyone has the space for that. And finally, while solar panels themselves are very low maintenance, they do degrade over time, usually about 0.5% in efficiency per year. But even after 25 years, most panels still produce around 80% of their original output. Despite these challenges, the momentum behind solar energy is enormous. Countries like China, India, Germany, and the United States are investing heavily in solar infrastructure. Entire cities and even countries are pledging to go 100% renewable, and solar is at the center of that vision. In rural areas without access to power grids, solar panels are bringing electricity to homes for the very first time, powering lights, charging phones, even running medical equipment. It's transforming lives, not just cutting bills. So the big question is, should you go solar? If you live in an area with decent sunlight, if your roof gets good exposure, and if there are financial incentives in your region, the answer is probably yes. It's not just about saving money. It's about gaining energy independence. It's about making a personal contribution to fighting climate change. And it's about taking control of your energy future. In the end, solar energy is more than just technology. It's a mindset shift. It's a movement. It's the realization that the power we've always needed, the power we've been burning coal and oil to get, has been shining down on us all along, free and clean and endless. So the next time you feel the warmth of the sun on your skin, remember, that same light has the power to run a blender, a factory, a city. And now, thanks to solar panels, we're finally learning how to use it. Thanks for watching. If you found this video helpful or inspiring, hit that like button, share it with a friend, and don't forget to subscribe for more deep dives into the science and technology shaping our future. Until next time, keep looking up.